Some jobs are specified to use staples on ASJ jackets and butt strips without the self-sealing lap feature. The staples are special outward clinch type which penetrate the jackets and then bend out to clinch them together. On hot lines, just pop them in about 1/4 inch from the edge, and the same for the end joint. For cold lines, it's necessary to brush coat the lap with a rubber type adhesive. Apply a thin, even coat, allow it to dry until tacky, then fold it down, rub to seal, and secure with outward clinch staples. Daub the staple heads with adhesive to seal. You know Murphy's Law. If something can go wrong, it will. You should review the specifications and work orders for each job and look it over for possible problem areas. Some of the common ones are pipe sleeves through walls or floors that are too small for the insulation to pass through. Or pipe hangers are sized wrong for the insulation. Or the pipe is located where there's no room for the insulation. You should notify the pipe foreman or job inspector of any problem areas. You don't want the plumber or pipe fitter to spoil your job because Murphy was on his. Besides problem areas that can be fixed, there are other challenges to meet on any piping insulation job. The first is all piping is not in nice straight rows. There are elbows, valves, couplings, flanges, unions, reducers, and branch runouts to deal with. And there are several types of hangers to support the pipe. Ones that are in direct contact with the pipe, called clevis or split ring. And the one like we have here, which goes on the outside of the insulation with a rigid support piece at the bottom of the insulation. These hangers are used primarily for cold or chilled water piping. On many jobs, a temporary spacer block support has been installed under the pipe at the hangers. Remove the block and adjust the hanger rod if this is not done by another trade. Do not move the lock nut at the top of the hanger. This is fixed to provide slope to the line. Measure from the end of the near section of insulation on the pipe to the center of the hanger. Open up a section of jacketed fiberglass pipe insulation by making a relief cut through the hinge side of the section. Do not cut through the jacket. Now, what you need to do here is to insert a rigid insulation piece or a wooden block to support the weight of the pipe. This is done by cutting a piece out of the half section of insulation that will be on the bottom and inserting rigid insulation such as cellular glass, calcium silicate, or wooden block into that section. Cut down to the facing, not through it, and lift out the fiberglass and replace with the rigid material. Install this section and slide it into place at the hanger with the insert at the bottom and centered in the hanger. Lay the jacket laps down straight and even, avoiding wrinkles. Place a sheet metal shield under the insulation, being careful to center in the hanger, and be careful not to puncture the jacket with the corners of the shield. Sometimes the mechanical contractor furnishes the shields. Make sure the pipe hanger is straight and plumb. Run the hanger rod nut back to the original position with the hanger tight against the lock nut and tightened with slip joint pliers. When finishes other than factory jackets are required on the insulation, they should be applied before the sheet metal shield is installed and the hanger is replaced. Another hanger type used primarily on plumbing hot and cold water lines is a contact type. Insulating around this hanger involves opening up a section of covering like we did for the previous hanger. Measure the distance from the end of the nearest insulation section to the center of the hanger and cut out pieces of the insulation so it will go around the clevis. Then make a shallow cutout to accommodate the hanger clamp ring and strip out the insulation. Do the same for the other half. Apply the insulation to the pipe and pack any voids at the hanger with scrap. Make sure the cutouts fit and the insulation closes tight. In addition to these types of hangers, there are welded, saddle type, and T or angle iron supports called shoes, which are normally used on hot pipe systems. This one is a saddle type. Cut a notch out of the insulation to fit around the saddle. Save the cutout piece, trim, and slip inside the saddle to eliminate bare spots. Form jacket flaps on the end of this piece to fold down and seal, or coat the exposed ends with mastic. That pretty well covers hangers and saddles. And what we have next on our piping system are branch runouts. When obstructions are close together like these, make cuts for the first obstruction, then measure to the center of the next straight portion and cut the insulation at this center point. This allows the insulation to be turned, so cutouts are made in the joints of each section. Let's do one of these step by step to show how cutouts are made for branch T connections. Measure from the end of the last piece of insulation applied to the main line to the center of the branch line and mark this dimension on the insulation. Next, measure the outside diameter of the branch line and scribe a circle on the insulation at the mark. Then cut out the hole. Make sure it's positioned so the jacket flaps line up with the other insulation on the line. Make relief cuts and strip out the insulation so it will fit over the T and apply this piece. Do the same for the opposite branch runout, making sure you cut the hole 180 degrees from the previous one. The mating branch piece is cut to form a fish mouth to fit against the mainline pipe insulation. Trim it to nest against the curved surface and install. If a cold line application, use a vapor retarder mastic to seal the joints. There are other ways to insulate T's, such as we've just done. One is to make cuts like these and join together. As we move down the line, we find an elbow. What do we do here? Well, first we insulate right up to the fitting on both pipe legs. Measure and cut off pieces to fit snug against the L. Place the hand-cut ends toward the fitting and make sure the jacket laps line up with the adjoining insulation. Now you're ready to insulate this fitting and others you'll run into on pipe insulation work. We'll cover these in the next session. Let's review what we've learned so far. First, you've seen how easy it is to work with fiberglass. It cuts easily and cleanly. It can be skim cuts and material peeled out to fit around the welds and flanges. It's lightweight, does not break, and comes with the jacket already on the insulation. The self-sealing lap feature makes for a neat, tight job. Second, it's important to check the job over before you start in case there are problems that need to be corrected. Third, you can save time by placing insulation you'll need for a day's work along the line. Fourth, it is necessary to keep the insulation dry. Store indoors wherever possible. If outdoors, place on skids and protect with tarps. Fifth, when taking measurements for cuts in pipe insulation, always measure from the last piece of pipe insulation to where it is to be cut off, and not the opposite way. This helps prevent laps from being turned in the wrong direction. Sixth, on cold work, always seal off the jacket to the hanger rods when contact-type hangers are used and down to the pipe at fittings. Also, seal any joints or punctures in the jacket with vapor retarder mastics. Seventh, neatness counts if you want to do a quality job. Keep your work area neat and orderly. Clean up scraps every day and store equipment and ladders out of the way. Keep your laps in a straight line and turned away from view. Always maintain a safe work environment and use proper safety equipment on all jobs. Next video lesson, fittings, a simple challenge if you know how.